All right, we are solving a logarithmic equation. So we'll do number 12. So your notes are, the title of your lesson is Solving Logarithmic Equations. All right, so say you're given log base 3 of 4x plus 8 minus 7 equals negative 3. Well, we're looking to solve for x. So we need to isolate the x variables. We're going to add 7 on both sides to get rid of that, subtract 7. Negative 3 add 7 is 4. And then drop everything down. Log base 3, 4x plus 8. From here, make sure you understand your circle of life. Remember, b to the x power equals this answer, this argument. For example, log 2 of 8 equals 3, right? Because 2 to the third power equals 8. So make sure you're using these arrows when needed. So here's an example. We've got our argument right here. We've got our base right here and our exponent, just like this. Base is 3. Our argument is 4x plus 8, and our exponent is 4. So show your arrow. Log, or 3 to the 4th power, 3 to the 4th power equals our argument. 3 to the 4th power means 3 times 3 times 3, which is 81. 4 3's being multiplied by each other. Just bring this down. We're isolating x, so we're subtracting 8, which gives us 73 equals 4x. Divide by 4 to isolate the x. Divide by 4. So x equals 73 over 4. That is our answer. Let's try another one. Let's see if it gets harder than this. Of course, they get more difficult, or I don't want to use the word difficult, but they get different. So say you have log of y plus 5, and you're adding log 4. And you're making that equal to log of 72. Well, make sure the logs have the same base. Base are all the same there. The bases by default, if you don't see a base, is 10. So, in order to do this, make sure you know your properties of your logs. This is your product property. If you're adding the same based log, you multiply the arguments. So let's take the log and take your argument, y plus 5 times this argument, 4. And then drop this down, log of 72. Multiply 4 times y. That's 4y. 4 times 5 is plus 20. Equals log 72. If you have the same base, you can set the arguments equal to each other. So make sure you square those. You're showing your work that you're setting these arguments equal to each other, because we're looking to solve for y. So right now we're just setting the arguments equal to each other. We're dropping the logs because we don't need them. This is a rule that if you are equaling the same base log, which is base 10 here, you can equal the arguments. So solve for y like normal, subtract 20 to get rid of that, add 20, subtract 20 over here. 72 minus 20 is 52. 4y equals 52. How do you solve for y? Divide by 4 on both sides. 52 divided by 4 is 13. So y equals 13. That's another example. So make sure you have these examples in your notebook, example 1, and then example 2. Let's try another example. All right, let's try, what if you have log of 3, log base 2 of 3, and you're adding log base 2 of x minus 2. And you're setting that equal to 4. Okay? So you have to use your problem solving skills. It's a puzzle. So we're looking to solve for x. We've got the same base here. So we can multiply our arguments. So bring your log base 2 down, and then go ahead and multiply your arguments. And bring down the equals 4, just bringing it down. So log base 2 of 3 times x, 3 times negative 2 is 6, minus 6 equals 4. Make sure you notice this pattern. If you see a base, you see an argument, and you see an exponent, do your circle of life. Your little loopy thing, loopy-doo. All right, so that means 2 to the 4th power equals this argument. Why are we dropping the log? Because that's what this expression means. That this base, log base 2 of 3x minus 6 equals 4 means 2 to this power equals this argument. That's what that means. So that's what you're going to write. 2 to the 4th power, 2 times 2 times 2, 4 times 4, that's 16. Add 6 on both sides. Sometimes you'll have fractions. 22 equals 3x. Divide by 3 to get x by itself. X equals 22 thirds. Don't forget, if you end up with a negative, say you end up with like a negative x equals a negative 6, x equals 6. So this is not your answer. This is your answer. Okay. That's just an arbitrary side note. Okay, that was your example 3. Let's try another example. All right, example 4. Say you have log 4 of 108 minus log 4 of 9 equals log 4 of 7a minus 9. Okay, we're looking to solve for a, the missing variable. So let's look at our pattern here. We have the same base, so we can work with this equation. What property is this? Subtraction. So we can divide our arguments. So take log 4 of 108 divided by the other argument, 9. Bring this down. What is 108 divided by 9? 108 divided by 9 is 12. Make sure you double check your math or use a calculator. 12. Log 4 of 12 equals log 4 of 7a minus 9. Okay, same base, equal. That means set the arguments equal to each other. 12 equals 7a minus 9. 7a minus 9 equals 12 because 108 divided by 9 is 12. Set the arguments equal to each other. Okay? Add your 9. Add your 9. It's 21. Divide by 7. A equals 3. Again, don't forget if you, for example, had a say for some reason you had a negative a equals a negative a equals 3, for example, make sure you solve for a, which is negative 3. Okay. So those are some examples. There's a few more. So it can get a little bit harder or different, right? Not harder, but different. Example 5. Say you have 3 times log base 2 of k equals 3. You're like, this looks crazy, right? Well, make sure you use your power property. So you can't really work with this because of this random 3. You could divide this by 3. You could do that. Divide this by 3. Divide this by 3. Let's try another way as well. That way you can see both ways. Bring that coefficient back as an exponent. You can do that. That is a property of logs. So 3 times log 2 of k is the same thing as saying log 2k to the 3rd power. These are the same thing. Okay, so now you can use your circle of life, which is 2 to the 3rd power. Oh, it's right there. Equals k cubed. So 2 to the 3rd power. You can sit it anywhere. Thank you, Ms. Johnson. 2 to the 3rd power equals k cubed. 2 to the 3rd power is 8 equals k cubed. You want to get k by itself, so you want to take the 3rd root. Take the 3rd root. So k equals 2. Because 2 times 2 times 2 is 8. Another way to do that, like I said, you can do a shortcut way, which is preferable, but sometimes you can't do shortcut ways. This one you want to do the shortcut way as well. You can do the shortcut way where you divide this by 2. So let's go ahead and try it. We have 3 times log 2k equals 3, right? So divide this by 3 to get rid of the 3. Get rid of that coefficient. And then 3 divided by 3 equals 1. Base, argument, exponent, do your loop-de-doo, loop, loop, loop. 2 to the 1st power equals k. 2 to the 1st power is 2. So I want to show you both ways, and that's how you do those kind, okay? So go ahead and work on your worksheet. All right, one more thing to add. You have to make sure you check for extraneous solutions. So for example, and that's what it says, solve and check for extraneous solutions, meaning solutions that actually don't work. So say you have log 9 of 6 minus 3w, and you equal that to log of 9 of negative 2w. So we're going to go ahead and set the arguments equal to each other because we have the same base, right? So 6 minus 3w equals negative 2w. You want to go ahead and get w's over here, numbers over here. So we're going to go ahead and get rid of this this variable term here, so we can put it over here. And then you want to get rid of this number over here and put it over here. Okay, so 6 minus 6, make sure you subtract 6 over here. You're adding 2w here, adding 2w here. So negative 3 plus 2 is negative 1w, right? Bring down negative 6, divide by negative 1, you'll get 6. Or you can do this as well. Negative 3w add 2w is negative w. So it's the same thing, and you're swapping these signs because we're looking for a positive w. So w equals 6. I'm hearing talking. Stop talking, please. W equals 6. Now, that's not your final answer. Make sure you're checking your solutions because you'll find out that there is no solution for this one, actually. So make yourself a checkbox on every question that you have and plug it back in. So take this argument, 6 minus 3w, right? 6 minus 3 times 6. So plug this 6 into this w. 6 minus 3 times 6 is negative 12. So that means you're having a log of 9 to negative 12. It's impossible to have a negative argument. Look at this one as well. Log 9 of negative 2w. Plug in 6 for this w. So log 9 of negative 2 times 6 is also negative 12, right? This is not good. You're not supposed to have a negative argument. Why is that? Because 9 to what power gives you negative 12? There is no power. All the logs that we've been working with have been a positive argument. So log 2 of 8 would be 3 because 2 to the third power gives you 8. So x equals 3, right? Your argument can never be negative. All of our arguments have been positive so far. Example, these are all of our arguments right here. Are any of these negative? No, these are all positive numbers. So that means your arguments can only be positive. This argument ends up being negative. The 6 does not work. 6 minus 3 times 6 will give you a negative argument up here. So this one has no solution. Your answer would be no solution. So go ahead and try number 2 on the back. You're going to find out that this solution is no solution because you cannot have a negative argument. You'll find that out, so go ahead and try it out and check.